students. Today we can discuss about soil physical property. It is an easy topic and comes under the soil physics. So let's go into the chapter directly. Before the topic, everyone knows what is a physical property. Without changing the chemical identity of a substance, what we can measure, that is a physical property. For example, length, color, density, mass, elasticity, pressure, volume, luster. Take an example like if we have a stone with us, we can measure its length, we can see its color and say whether it is black, white, or whatever it is. Or if we know its mass and volume, we can measure its density. Okay, so for all these properties, we are not using any chemical reagent. We are not changing the chemical identity of the substance. But for measuring the pH EC of any solution or substance, we are using various reagents to change the particular substance chemical structure and identity. So we can say pH, EC are chemical property. So length, color, density, mass, etc. of any substance, they are physical properties. So we can see, hear, feel, touch, smell, and measure any physical property. So, as in the case of soil also have some physical property. So, by using it, we can determine a soil's physical state and structure, which are the physical properties of the soil. So, let's understand the physical properties of the soil through this class. So, these are the physical properties of soil like texture, structure, bulk density, consistency, crusting, temperature, aeration, etc. So these properties will determine whether the soil is suitable for agriculture, environmental or engineering purposes. So when we look around, we can see plant roots, the root penetrations, heat and air flow, water and nutrient availability, chemical and biological property, etc. So everything is related to soil physical property. So this picture shows the components in a soil. Uh, Among the components, half is solid. For example, mineral is 45 percentage and organic matter is 5 percentage. They are solid component. And the rest 50 percentage, it contain 25 percentage air and 25 percentage water. Okay. So from the here we can see in solid phase the soil has mainly as mineral particles, that is 45 percentage. So this mineral portion is of different size and shape. So if we have a soil with us or a land with us, we can see smaller and larger particles in that soil. The larger particles, that is greater than 2 millimeter in diameter, they are known as coarse fragment or larger uh, particles or rock fragments. So according to the size, there are gravels, pebbles, cobbles, stone, boulder. Like you can see the diameter or size also. So according to the size, they are grouped into these ranges. So we can see its picture. This is gravel. It is of 2 to 4 millimeter. It is pebble, 4 to 76 millimeter size. It is cobble, 76 to 250 millimeter in size. And this is stone, 250 to 600 millimeter. And this is boulder, such a greater size, that is greater than 600 millimeter sizes are known as boulders. Okay, so we can you can see this picture. Like, don't want to study this relative sizes, just to understand gravels, pebbles, cobbles, stones, boulders, they are large particles. So they will not contribute to the soil properties, important soil properties, and they make tillage very problematic. So we will consider the particles less than 2 millimeter, that is small size, for the soil classification, and they will contribute to important soil properties. So these particles are known as soil separates or fine earth or primary particles or textural fraction. So they have diameter less than 2 millimeter. You can see this is large gravel gravel means greater than 2 millimeter in size. So less than 2 millimeter size comes sand, silt, clay. Okay, so this is a size of a sand in relation to a silt and clay. So we can't see clay at this scale. It is invisible to our naked eye. So larger gravel, so, smaller than gravel. Sand is smaller than gravel. Silt is then very smaller than sand, and clay is invisible at this scale. So this sand, silt and clay, they are known as soil separates or fine earth or primary particles or textural fraction. So this 2 millimeter, greater than 2 millimeter, less than 2 millimeter, that this is classified on the basis of equivalent diameter. So this is a diameter of a sphere that has a velocity of fall in a liquid medium equal to that of specific particle. So we are taking a particle, and this particle will fall in at a velocity in the liquid medium. So that particle's equivalent diameter is the 2 millimeter, like that. We are classifying on the basis of that. So these are the soil separates: sand, silt and clay. So all these soil fractions, including the soil pore space between them, form this matrix of the soil. So whole soil consists of these soil particles plus pore space. And our soil contain different proportion of sand, silt and clay, and there is also pore space. So all together constitute the matrix of the soil. In the previous slide, I mentioned about the classification, right? So do you know who will do this classification? So USDA, ISSS in the International Society of Soil Science. USDA means United States Department of Agriculture, and BSI, British Standard Institution. They are doing this classification on the basis of several diameter, on the basis of this particle diameter. So these are several systems like ISSS, USDA, BSI. They classify the soil particles according to the various diameter. So I took this table from soil science treatise. Can study. You have to study this table like ISSS and USDA. This classification is very important. So in all these classification, you can see the clay less than 0.02 millimeter. Here also clay less than 0.02 millimeter and clay less than 0.02 millimeter. So you can understand that any particle less than 0.02 millimeter, or you can write it as 2 micrometer. 2 micrometer. So they are clay particles. So among here, ISSS and USDA, they are the widely used classification system. So for coarse sand, 2 to 0.2 millimeter, they are known as coarse sand. Fine sand, sand is of two types, coarse and fine. So coarse sand means 2 to 0.2 millimeter. Fine sand means 0.2 to 0.02 millimeter. Silt is 0.02 to 0.002 millimeter, and clay less than 0.02 millimeter. While you can see the USDA classification, in this classification, clay is 0.002, less than 0.002 millimeter, while silt is 0.05 to 0.02 millimeter. And these are sand particles. So very fine sand, medium sand, coarse sand, very coarse sand. These are sand particles. So when the any particle have diameter 0.05 to 0.1 or 0.10, we can't say 10, 0.1. They are very fine. 0.1 to 0.25, they are fine sand. 0.25 to 0.5, they are medium sand. 0.5 to 1 millimeter, they are coarse, and 1 to 2, they are very coarse. So you have to study all these very thoroughly. They can ask like the particle size of sand, according to USDA, you have to answer 2 to 0.05. This upper limit and your lower limit you should be thorough. Clay will always have 0.02 millimeter less diameter. From 0.02, the diameter of silt and sand starts. Silt starts. So in USDA, upper limit of silt is 0.05, while in ISSS, upper limit of silt is 0.02. Okay, that is the difference here, 0.02, here 0.05. And in ISSS, sand is only coarse and fine, while in USDA, very coarse, medium, fine, and very fine. So you have to just understand and thoroughly study the classification. BSI, British Standard Institution, that is not an important classification, but ISSS and USDA are important classification. Then for easy understanding, you can use this photo. Coarse sand, then this is fine sand, much smaller than coarse sand. This is silt size, and this dot they are clay. And International Society of Soil Science, clay, if for every don't you don't want to look this United States Public Road Administration, which is based on engineering purposes. ISSS and USDA, clay is same, 0.02, less than 0.02 millimeter, while in silt 0.02 comes for International Society of Soil Science, while in USDA 0.05 comes. Then gravel, gravel means greater than 2. So limit of sand particle size, according to ISSS is 0.02 to 2. Then here USDA 0.05 to 2 millimeter. Just study thoroughly. And we can see the properties of different types of soil separates. So first it is sand. So you can see sand from beach. Take an example of beach soil. So that soil contains sand fraction at high proportion. You will be surprised to know that soil contains sand fraction, silt fraction, and clay fraction. But sand will be dominated. The properties of sand will be dominated. So we will call it as a sandy soil. It is sandy soil, right? Because this soil contains sand fractions at high proportion. So imagine a beach soil. Okay. So you can see the particles directly by our eye. So it is visible to the naked eye. Before that, you have to look the it's a diameter classification of diameter according to ISSS and USDA. Okay, 2 to 0.02 millimeter, then 2 to 0.05 millimeter for sand fraction. Okay, then this shape of this sand fraction is spherical, cubical, or irregular shape. See, did you observe that? Like if you don't observe, next time if you visit a beach, you have to observe it. We are studying soils and we are soil scientists, so we have to observe these things, such things. So after the wave of this water come, water comes, you can see it will dry very quickly. Will not The water will not stand on this soil for such a long time. So we can't find it moist at all the day. Even if there is no sunlight also, this water will go very quickly. Okay, it is because it have large pores between the soil particles. Through that pore means empty spaces. So through that water will flow and drain quickly, and also air can circulate through it very easily. Hence it can't hold water and nutrients. So water and nutrient holding capacity is low. Like water, nutrients also can't stand in the soil for such a long time, so it will drain, or it will drain away very quickly. Okay, so this is the reason why we can't grow rice in sandy soil. Why? Rice needed saturated water through its life stages. Okay, so water can't stand on the sandy soil means we can't grow rice. Okay, so coming back to the point, uh, so its drainage is also excellent because water flows very quickly. Aeration status is very excellent, and the common mineral present is quartz, or silicon dioxide. So this is an important point. Common mineral present in sandy fraction is quartz. Okay, then so many other minerals also present, but quartz is a dominant mineral. So if we take the soil in our hand, will it stick to our hand? No, no, right? It will not stick. So if we make any shape of out of it, and after we apply pressure, and we can't bring that shape back, that shape will be destroyed very fastly. So have you ever noted it? So this property is known as the plasticity. This one, plasticity. So there it is non-plastic. Okay, so sand fraction exhibit non-plasticity, and we can't it will not stick to our hand, so it is non-sticky. And its specific surface, it is very low. Its area, its particle size is very large, so its surface area will be very low. You all know that why it is like that. And it do not have a swell shrink property. It will remain as such when it absorb water or when it dry. It will not swell and shrink respectively. Then we are estimating sand fraction by using sieve, different size. Sieve means 2 millimeter, greater than less than 2 millimeter sized sieve, and 0.02 millimeter also we can use a sieve as sieve. Then its susceptibility to wind erosion, it is moderate. Its water erosion susceptibility is low, while compactness, it is very low. It will not compact. Then buffering capacity is very low. Macropore and micropore, it is high and low, again, respectively. And fertility, it is very low. So we can study this about macropore and micropore. Okay. Then let's see the properties of clay fraction. Clay fraction. We can read this later. So this clay fraction, what is the range of diameter according to IEEE and USDA? It is less than 0.02 millimeter. Okay, in both system, the diameter is less than 0.02 millimeter, and we can't see it through our eyes, right? Clay particles are not visible with our naked eye. It is visible only through electron microscope, and it is of platy or needle like or spherical in shape, and it feels sticky when wet and hard when dry. Water and nutrient capacity, all these properties are opposite to the sand fraction, because it clay can hold water and nutrients. It will not allow the free movement of water and air. So its water and nutrient holding capacity is very high. Then its drainage is very poor, and aeration status is also poor. And the common mineral present are secondary minerals like kaolinite, montmorillonite, illite, and its swell shrink property is low to high according to the type of secondary mineral present in it. And it possesses high plasticity, very stickiness, and we estimate it through sedimentation process. Here I have forgot to add one thing. Its specific surface is very high compared to sand fraction and silt fraction. And wind erosion susceptibility is very low because it is very small particle. So wind erosion is very low. Water erosion susceptibility is low when it is aggregated and high when not aggregated. And high compactness, high bulk density, and macropause is low, and micropore is very high, and fertility status is high. So, and about silt fraction, it is intermediate between sand and clay particles. So, which is the lower limit of sand fraction diameter? That is the upper limit of silt fraction, and 0.02 to 0.002 millimeter. It is the size according to ISSS, and 0.05 to 0.02 millimeter. It is a size according to USDA classification, and we can see silt fraction only through by using ordinary microscope. Like we don't want electron microscope to see silt fraction, we can see by ordinary microscope, and it is spherical, cubical, or irregular shape like sand fraction. And while we touch sand, we will feel grittiness. Grittiness means we can feel that touch. While touching silt, we can feel like flory or talcum, like powdered. Like it is like that. And when we touch clay fraction, it will stick to our hand, and it is dried. It is very hard to touch. So that's why it's written feel sticky when wet and feel hard when dry. And water nutrient holding capacity is medium to high. Drainage is also medium to high. Aeration status is medium to high, and this is like intermediate between sand and clay fraction. Then common mineral present are feldspar, quartz, hematite, mica, and soil shrink property is very low. Specific surface is medium, and plasticity and thickness are very slightly. And like clay fraction, it is determined by sedimentation process. And you can see in sand fraction, swell shrink property is nil. It has no swell shrink property. But in silt fraction, it's very low, and it is low to high in clay fraction. So you have to study it by comparing all. Just understand and study, then you can see or you can memorize the differences. Then wind erosion and water erosion. This is important. Silt fraction has high susceptibility to wind erosion and water erosion compared to sand and clay fraction. And we will think that either clay or sand fraction will have high susceptibility to wind erosion and water erosion. But silt fraction has high susceptibility to wind and water erosion. Okay. Then properties like compactness, buffering capacity, macropause and micropause, they are medium. Fertility is also medium. So what is this buffering capacity? So it is the ability of a soil to resist any changes in the pH. Like this clay fraction is a chemically active fraction. It is always chemically active. So it will have a high buffering capacity due to many other reasons also. Okay. Then some extra points regarding silt fraction. Soil dominated by silt fractions are more compact. Then and forms surface crust under the impact of rain and results in poor drainage and poor aeration status of soil. So you have to means consider these points also. Uh, the silt fraction, even if it contains silt fraction, it will get more compactness and it will form surface crust. And this after forming the surface crust, poor drainage and poor aeration is resulted. So another level of question is what is a skeleton of soil? So sand and silt is referred to as skeleton of soil, and flesh of soil it is clay. So we understood that the soils will contain different soil property. Soil particle. So we saw different types of soil particles based on the size also, diameter also. Right. Okay. So all this for a soil, all these soil particles are present. All these soil particles are present. But if, for example, we have sandy soil, like in beach, does it contain only sand fraction? As I have told earlier, answer is no. Actually, it contains sand, silt, and clay also. But where is the sand fraction? We can't feel the clay, right? Okay. uh, and actually the beach soil clay fraction is there, but it is very low, its property is low, its amount is low, and sand fraction is dominating in the beach. So soils like sandy like beach soil, it is of sandy texture, so we can call them sandy soil. So understand this concept first, then only you can understand the soil physical property. So what did I say? Is that what I have to say is that a soil contain all these soil particles, but in different proportion. So we can see the different soil properties. So this I mean to take an introduction to the soil physical property. So let's see other properties through coming classes. Stay tuned. Study this portion. If you are studying this PPT or what I am saying, you don't want to read soil science treatise book, because I have added every points from soil science treatise book and also fundamentals of soil science. Just uh, listen and understand the concept properly, and if you want to read the book, just read once, don't want to give much more time to towards reading, because I have included every each and every line from that book. So understand the concept, prepare well, and thank you everyone. If you have any doubt, you feel free to ask in the comment box. Okay, I'm very happy to receive suggestions and also any kind of comments, like suggestions. So thank you everyone. Study well, prepare well, and see you in the next class. Stay tuned. If you're watching my channel for the first time, and if you like my videos, if you find it useful, please watch it and subscribe my channel for getting more videos like this. And okay, thank you everyone.